During the previous lesson, we have learned to write the formula of an ionic compound using the crisscross method. In this lesson, chemical bonding, we will discuss in details how an ionic compound is formed. Ionic compounds are formed between cations and anions due to the formation of chemical bonds. At the end of this lesson, you will be able to indicate the number of valence electrons of an atom, write its lowest dot symbol, deduce the valency of an atom, explain the Duet and Octet rule, and finally explain bond formation between two ions to form an ionic compound. You are already familiar with the term valence electrons, which is the number of electrons in the outer energy level. Let's take an example, C6. As you know, before finding the valence electrons, you should first write the electron configuration. So number of protons equal atomic number, and in a neutral atom, protons are equal to electrons equal to 6 in this case. So now we can write the electron configuration of carbon, which is K2L4. The valence electrons of carbon is 4, since the number of electrons in the outer energy level is 4. Once you find the number of valence electrons, you can write the lowest dot symbol. The lowest dot symbol shows the distribution of valence electrons around an atom. To represent the valence electrons, we use dots. Keep in mind that the maximum number of valence electrons is 8. When you distribute the electrons, you should place them evenly and in the following direction as you can observe: up, down, right, left. Up, down, right, left. Let's take an example. We have already found that the valence electrons of carbon is 4. Below we can see two methods of writing the lowest dot symbol. Method 1 and method 2. So which one is correct? In the first method, the electrons aren't distributed evenly, so it is wrong. Thus, the second one is correct. In the first application, you are asked to write the electron configuration and the lowest dot symbol of each atom. Don't forget to pause the video, then check your answers. So to write the lowest dot symbol, you should find the valence electrons before. We start by writing that the number of protons equal to the atomic number, and in a neutral atom, the number of electrons is equal to the number of protons. Now you can write the electron configuration. The electron configuration for sulfur is K2L8M6, so its valence electrons is equal to 6. Now you can write the lowest dot symbol. Don't forget to distribute the electrons evenly as shown. Up, down, right, left. Up, down. Here you find the solution for parts B, C, and D. If you have any mistake, please resolve application 1. Atoms should become stable, which means that their outer energy level should become saturated or hold the maximum possible number of electrons. That's why an atom can lose electrons to become a cation and have a positive charge, or gain electrons to become an anion and have a negative charge. The number of electrons lost or gained by an atom to become stable is called its valency. Keep in mind that the energy level K is saturated by 2 electrons, while L and M are saturated by 8 electrons. Don't forget that energy level N is not saturated by 2 electrons. Here we have a model of the magnesium atom. The number of electrons of magnesium is 12, and its electron configuration is K2L8M2, so its valence electron is 2. Now for magnesium to be saturated, it can gain 6 electrons to become saturated with M8, or lose 2 electrons to become saturated with L8. However, losing 2 electrons is easier than gaining 6. That's why to become stable, magnesium loses 2 electrons. Thus, its valency is 2. On the other hand, we have a model of the sulfur atom. The electron configuration of sulfur is K2L8M6, where its valence electrons is 6. So how can sulfur become saturated? It will gain 2 electrons to become saturated with M8, which is easier than losing 6 electrons. Thus, its valency is also 2. Noble gases that are in column 18 have a saturated outer energy level, so they are stable and their valency is 0. In this application, you are asked to find the number of valence electrons and valency of each atom. Remember, you have to write the electron configuration of each atom before you start. Valence electrons is the number of electrons in the outer energy level, while valency is the number of electrons an atom will lose or gain to become stable. So for calcium, it is easier to lose 2 electrons to become saturated with M8, and sodium will lose 1 electron, while nitrogen will gain 3 electrons to become stable with L8, and fluorine will gain 1 electron. The valency of neon is 0 since it's already saturated with 8 electrons because it's a noble gas. Each atom is saturated by a different number of electrons. Example, helium, its electron configuration is K2, while argon is K2L8M8. Since the outer energy level for helium is K, then it is saturated by 2 electrons only, while argon is saturated by 8 electrons since its outer energy level is M. So atoms can either follow the Duet rule if they are saturated by 2 electrons and their outer energy level will be K, or the Octet rule if they are saturated by 8 electrons and their outer energy level will be L or M. Don't forget, atoms are not saturated by N2. Now solve application 3, where you will find the number of valence electrons and valency of each atom. Deduce whether each atom follows the Octet or Duet rule. As you can see, potassium, oxygen, and phosphorus follow the Octet rule since the outer energy level is saturated with 8 electrons, while hydrogen and lithium follow the Duet rule since the outer energy level is saturated with only 2 electrons. We discussed previously that ionic compounds are formed from a cation that loses electrons and an anion that gains electrons. In this part, we will discuss how these compounds are formed. Let's take an example, magnesium oxide, that is made up of 1 magnesium atom and 1 oxygen atom. The magnesium atom has 2 valence electrons, so it will lose 2 electrons to become stable, whereas oxygen has 6 valence electrons, so it will gain 2 electrons to become stable. 2 electrons will be transferred from the magnesium atom to the oxygen atom. This will lead to the formation of magnesium oxide, where an electrostatic force forms between the 2 ions. This electrostatic force is called an ionic bond. It holds cations and anions. Keep in mind that electrons are transferred from the cation to the anion, which forms an ionic compound. An ionic compound is formed between metals found in column 1 or 2 and nonmetals. There are other types of bonds between atoms, but we'll keep that for next year. Each time you are asked to explain the bond formation, you are supposed to mention the number of valence electrons, indicate whether the atom will lose or gain electrons, write its ionization equation, and finally you have to state that an ionic bond forms between the 2 ions due to an electrostatic force. So let's take an example. Given that the electron configuration of sodium is K2L8M1 and of chlorine is K2L8M7. Each time you are asked to explain the bond formation, you have to write the following steps. Let's start with sodium. Sodium has 1 valence electron, so it can lose 1 electron to become stable and follow the Octet rule. So it will form sodium ion that has the charge Na+. The ionization equation is Na will give Na+, plus 1 electron. On the other hand, chlorine has 7 valence electrons. It will gain 1 electron to become stable and follow the Octet rule. So it will form chlorine ion that has the symbol Cl-. The ionization equation is Cl plus 1 electron gives Cl-. Then finally, you have to write, due to an electrostatic force between the 2 ions, an ionic bond will form to give an ACl compound. These steps should be always followed when you are asked to explain the bond formation between 2 ions. In Application 4, you are asked to explain the bond formation between each pair of atoms. Refer to the previous slide to revise the technique that you should use to solve this question. Now you can check your answers. Don't forget that each time you are asked to explain the bond formation, you have to include the following: number of valence electrons, whether the atom lost or gained electrons, its symbol, its ionization equation, and finally you have to state that due to an electrostatic force between the two ions, an ionic bond will form. In order to write the formula of the ionic compounds, you can use the crisscross method. Hope you found this lesson easy. Please revise the notes well and resolve each application. I will send extra exercises next week. Don't forget, stay home, stay safe.